Hey guys, welcome back to this channel, and in this video, like I promised last time, I'm going to actually be presenting and explaining the binomial distribution formula to you guys. So if you haven't watched my last video, in that video I introduced the binomial distribution and tried to explain it a little bit to get you a little bit more familiar with it and for you to have a feel of it. And now I'm actually going to be explaining the formula. So just so you know, if you're feeling a bit confused, I really recommend going back and watching that first video or any other video about binomial distribution for that matter, because I think this is one of those cases where you have to get the logic or kind of intuition behind it before you start looking at the formula. So let's do a quick recap of the requirements that we need to have for the binomial distribution, because that's obviously going to influence our formula. So first, there has to be a fixed number of trials, and for example, let me apply all of these requirements to shooting a basketball. For example, I shoot a basketball 5 times. Then there have to be 2 possible outcomes, a success and, so to say, a failure. So for example, a success would be me making the basketball into the hoop, or a failure would be me missing. And then there always has to be a constant probability of successes across these trials. So for example, in my case, if the probability of me making the basketball into the hoop was 1/2, it has to be 1/2 for every single trial. And then lastly, the trials have to be independent of each other. And what that means is, for example, the success of one trial doesn't influence the success of the next trial. So for example, if I make a basketball in once, that should not influence whether I make it in the next time. Right? And that goes together with the probability of successes being constant across all trials. So let me quickly present the formula. This is it. It might seem a little bit confusing and a bit daunting because what are these brackets? What is this vector looking thing? It's not a vector, by the way, but I'm pretty sure you know this. And let's take it down bit by bit. So there are many variations of this formula, or they're all mean the same thing, of course, but you might see them in different forms. But I chose this one, and I am going to explain the components of this one to you, and then I'm going to show you some other options. So in this case, the P right here is probability, and we're trying to find the probability in this case of the R number of successes. So for example, what's the probability that in 10 trials I make 5 hoops, right? That's our R, the 5 times I make it into the hoop. And N is the number of trials. So for example, 10 trials, 10 times I try to shoot the basketball. R, 5 times I want to make it in. P is going to represent the probability of success. So for example, if the probability of me shooting a basketball is 1/3 for some reason, it's 1/3, then P is 1/3. And then Q is the probability of failure, which is just the complement to P. So to say it's 1 minus P. So it will be 1 minus 1/3, because again, there's only 2 possible outcomes, meaning that Q just has to be 1 minus P, which in this case is going to be 2/3. If I don't make the basketball, then I miss. There's no in between. So these are our variables, right? And these are the different types of formulas that you might see. Again, here, the difference is that you're actually expressing Q in terms of P, which might help some of you, might make it a little bit more confusing, who knows. This is just representing this in a different way, because if you don't recognize this, this is just the binomial coefficient, but just expressed in a different manner. And this is just us actually writing this out in terms of what you actually have to do. So this, and this, these parts are all equal. And again, this just reminds you that Q is the complement to P. So now let's actually take a look at what this formula is doing and why these components are there. So if you think about it, if we have, so to say, 10 trials and we want to make 5 shots, I'm going with the example that I used, and the probability of a shot is 1/3, right? So obviously you have these 10 trials, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in order for you to make these 5 shots, you have many different possibilities, right? You can make the first 5, you can make the last 5, you can make the 5 in the middle. They don't all have to be in order. You can have 1, 2, 3, 4, 5, all I know. So that gets confusing. But if we just ignore that for the fact, and we assume there's only one possible way to get this, what would it be? What would your first step be? Well, you would think that in order to make 5 shots in 10 trials, you would have to have 1 over 3 to the power of 5 times 2 over 3 times 5 again. And actually, to make this a little bit more clear, I'm gonna pick 4 shots because then you can actually see the difference in the coefficients. So then it's gonna be to the power of 4 to the power of 6. And why this might make sense, just in case, is because you have to make 1/3 is your probability of making a shot, and you have to make 4 of them, so you have to do 1/3 times 1/3 times 1/3 times 1/3. This is the probability of you making 4 shots, but then you must also miss 6 shots, so you're gonna have 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3, bear with me, times another one, 2 over 3. Yeah, I didn't do too many. And so we're multiplying here because this is a type of AND situation. If you've ever heard the explanation that you add probabilities when it's or you multiply them when it's AND, this is an AND situation because you must make the 4 and you must also miss the 6, right? So this right here, really all it's doing is representing what the probability of making 4 shots in 10 trials is, just by itself. However, now this takes actually all of these different combinations into account. And this actually gives us the number of the possible combinations, or ways, so to say. So, for example, I'm not going to draw all these out, but to make 4 shots, sorry. To make 4 shots in 10 trials, you can make the first 4, you can make the last 4, you can make the 4 in the middle, you can make a random combination, and so on. So there's different types of trials. And if you've studied the binomial theorem before, you know that this coefficient gives you the possible number of combinations, or the number of the possible combinations. So if we put that all together, we're going to see that what this formula is really saying, and I think it's really key to understand this because once it makes logical sense, you can't forget it, or it's really hard to forget it. So what we're saying is that when we're trying to find the probability of having our number of successes within n trials, what we're all that we're doing is we're multiplying the probability of, if there was only one way in which we could achieve this, we're multiplying the probability of having our successes in n trials, if there was only one way to achieve this, times the number of ways, which makes complete sense because in this case, this is an or situation. If we're looking at the different number of trials, we can have this, or this, or this, or this, etc. So we can have all these different possibilities that give us the same outcome, and so we add them together. And the number of times that we add them together is given to us by the number of ways, which is given to us by this right here. So let's do a quick example to really solidify this in our brains, and then we're done. So this is going to be our example. I just took the one from here. We have 10 trials, so our n is equal to 10. I want to make 4 successful shots. So r is equal to 4. And the probability of me making a shot is 1 over 3. So I want you to go and find the probability that in 10 shots, I make exactly 4. So try this by yourself and then come back and see whether you've done it correctly. So I would like to start off with kind of not reversing this, but I think it makes more sense. So what would you do if you had to find just one way that this could be achieved? Well, you would do 1 over 3 to the power of 4 times 1 minus 1 over 3, which is just 2 over 3, because again, these events, there's only 2 options. You can either make it or miss it. So you have to miss 6 times in order to make 4 times. And then this is, again, if there's only one possible way, but you have many possible ways, which is given to you by the binomial coefficient. So therefore, we do 10 factorial over, and again, this comes from our definition of the binomial coefficient, over 4 factorial over 10 minus 4, which is just 6 factorial. And if we calculate this, this is going to be 0.2276 roughly. So our probability of making 4 successful shots in 10 trials is 0.2276. So I hope you enjoyed the video, and my main goal was really for you to understand the logic behind this, because I think just the presentation might seem a little bit confusing, but really this makes a lot of sense. I hope you enjoyed, and see you next time.